you set the key. So we set the key, and we enable decryption, and now we apply this configuration change, and what we see is that they are Cisco Discovery Protocol packets, which are multicast, and ARP frames, which are broadcast. So then what we do is we carry out the attack. As we said, first what we have to do is start capturing every single frame that's on the air. We do this with AeroDump. Then we perform our fake authentication so that the AP believes that we are a web station. This executed successfully. And as you see, we don't have to have any knowledge of the key in order for that to work. And then we do our attack, which is using the -W option that we added to AirCrack. And now AirCrack is just waiting to hear an ARP frame. Once it does, it will flip it as we showed before and start sending it out again. So there it happens, and as you see, the number of ARP frames are increasing in the air because AirCrack is injecting more ARP traffic. And if we look in the Wireshark capture, which is decrypting everything because we set the key, what we can do is we can look at the frames, and that's a frame that we sent. As you can see, it has the 2DS bit set. And if you look on the right column, the IP addresses are all different. That's because when we apply the mask, we don't know what the IP address is going to end up being. We just change it to something different to try to avoid IP conflicts in the network. And these are all web frames that this is the response that was sent to us by the station. And since we're a web station, the AP sent it web encrypted. And now what we're going to do is we're going to run AirCrack and force it to detect the network as a web network. And what we did is that we patched it so when it did this, it completely disregards any TKIP frames so that the cryptanalysis works okay. So now it's going to start cracking. It's going to fail because it hasn't still captured enough traffic. And then we run it again. And in the meantime, it captured enough traffic to crack the web key. So there you have the web key. So basically, in the hardest scenario possible where you don't have any web stations, you can still crack the web key. Now what we're going to do is, since we looked at this and we said, okay, now we see that an AP running in this mode offers no additional security to an AP running only web. So what we started to do was to see if there was any other security features that Cisco offered in order to improve the security of this WPA migration mode. And what we found is an option called broadcast key rotation, which basically what they say is that in WPA migration mode, this feature significantly improves the security when there are no static web clients. Meaning our scenario, we only have WPA stations. So what we started to do was look to see what this broadcast key rotation did. And it basically, in the documentation, it says that what it does is that when there are no longer any web stations using the static web stations using the network, it generates a new broadcast key dynamically and sends it out to all the web stations, so that instead of using the statically configured web key, you're using a new random key. And in order to configure this in a Cisco AP, you have to use the broadcast key change command. You specify the number of seconds that the key rotates, and you have to specify this mode capability change. So basically what happens when you're using this is what we see in this diagram. You have a WPA station, and you're exchanging frames with the AP, and everything is working okay. And then the AP chooses a new broadcast key and informs the station of this fact by performing an EAPOL frame exchange. And now all the WPA stations have a new broadcast key set, which is the random and was picked by the AP. So then normal communications keep on going. And after a certain period of time, the key interval dies out, so you have to rotate the key, and a new key is chosen by the AP and sent to all WPA stations so that they can decrypt the broadcast traffic using this new key. And what happens when a web station joins is that it triggers an EAPOL frame exchange, but going back to the previous statically configured key so that everybody can use the same key and decrypt the traffic, as there's no way of having that informing that station of the random key. It has to go back and use the statically configured key, which is the only one that the web station knows. Then normal frame exchange occurs. And after a while, when that station leaves, when the web station leaves, the IP is once again free to choose a random key and inform that to all the WPA stations. So basically, in order to bypass broadcast key rotation, all we have to do is tell the AP that we have joined the network as a web station and that we can't do dynamic rotation. So basically, the AP falls back to the statically configured key, and we have exactly the same scenario as before. And if we look at what we were doing, this is the first step of the scenario of our attack mode. So basically, this feature does not enhance the security at all. It doesn't change any of its facts. So in order to bypass this, we do a fake authentication with Aircrack. Here I'm going to show a demo of this working. The first thing I'm going to do is set the web key in Wireshark and also set the WPA key so that Wireshark can decrypt both web and WPA traffic. Once this is enabled, I'm going to start monitoring the frames that are in the air. And I'm going to pick a filter looking for frames from our AP that are either web or EAPOL frame exchanges. EAPOL frame exchanges are encrypted with TKIP, so that's why I had to set the WPA key so that we could find the EAPOL frames and look at them decrypted. And what I'm going to see is that this is when the station joins and an EAPOL frame exchange occurs. This is a WPA station joining. And if we look at these are broadcast frames. They're web encrypted, but although Wireshark knows the web key, it can't decrypt the frames because these frames are encrypted with a random key that the AP chose. So if we try to crack this key, what we're going to end up cracking is a key that's only valid for a short period of time. So it's completely useless to crack that web key. So basically now what we do is we authenticate using the fake authentication. As you can see, now we are able to decrypt the broadcast traffic. Now we see that there are WLCCP frames and IGMP frames, and that an EAPOL frame exchange had occurred before in the capture, and that was telling the WPA station that was in the network what the new key was, which was the statically configured key. These are just analyzing the frames. So basically what I'm going to do now is deauthenticate myself. So now I have deauthenticated, and the AP will once again perform an EAPOL frame exchange with the WPA station, and once again broadcast traffic. We're not able to decrypt it even though it has web because it chose a new dynamic key. But this is how it works, but it's trivial to bypass because I can just fake being on web station, and this feature gets magically disabled. So we said, okay, let's see if we can find another scenario, different ways to mitigate our attacks. And one typical thing that people enable in web, if they have to have a web AP hanging around because they have, I don't know, some hardware that's not able to use WPA, is that they enable PSPF. What PSPF does is that it does not allow station-to-station traffic. Basically, on the diagram on the left, you have two stations. They can talk to each other because no PSPF is enabled. In the second case, when you try to send a frame from one station to the other, the AP drops that frame and says, this cannot be used. This feature was introduced by Cisco mainly to be used in hotspots, so that all the broadcast net bias and all that stuff that everybody would be shooting around when dead. And this has the advantage that if you enable this in a web network, there are certain attacks that you can't carry out. For example, the chop-chop attack doesn't work because you need the AP to forward frames to another station, and you have to go through the AP. So basically what this does is that this forces you to use some other types of attacks against a web network if it's configured with PSPF. And the only attack that you can carry out, and this is if you have PSPF enabled on a web AP, is to attack a station directly. Because if you try to go through the AP, it will never send the traffic forward. So basically you have to go through the attack directly a web station so that it generates new and more broadcast traffic, new web traffic that you can use to decrypt the key, to crack the key. So we said, okay, we don't have any web stations to attack because we're assuming that we're in migration mode and there are no web stations in sight. So this might be a security feature that does enable us to thwart our attacks in migration mode. Basically, what you see below is how to configure this in a Cisco IP. You have to use the port protected option. So we started thinking, okay, how are we going to manage to crack the web key under this scenario where we don't have any web stations, so we can't attack them. We have PSPF enabled, so the AP won't forward our traffic. So we started to look what the station did once we joined the network, what happened. And what we noticed is that each time that a station joined the network, in particular a web station, but the same happens for WPA stations, Cisco IP starts throwing around a lot of broadcast packets, which are web encrypted because they're broadcast. And if we decrypt them, we see that these are IGMP packets and WLCCP packets. WLCCP packets are Cisco's wireless LAN context control protocol, which is a protocol that Cisco uses to coordinate the APs, the access points. So each time the station connects, either a web station or a WPA station, Cisco starts sending out these frames by default. And the interesting thing is that WLCCP frames have a lot of the packet. You know it beforehand. As you can see, they're all fixed values. And the only thing that changes between them for this type of WLCCP frames is this destination and source MAC address, that even though it's encrypted inside the frame, we also have it in the header, the 802.11 header of the packet, which is plain text, so we can see it. So basically, we can know the plain text of the packet without having to decrypt it. So this gives us certain possibilities for cryptanalysis. So what we did was we came up with this attack that what we do is we authenticate as a web station without having to have any knowledge of the key, and we continuously send reassociation requests to the Cisco IP. And what the Cisco IP does is continuously send WLCCP packets back to us, which are web encrypted. So we then capture these frames, and using these frames, we crack the web key. The problem that this has is that Aircrack does not know how to do cryptanalysis on WLCCP frames. You only have to go back to the FMS mode, attack mode, and the FMS attack mode requires over 500,000 packets in the best case, and normally it takes up to 2 million frames for it to succeed. And the problem was that this attack was very, very slow, so capturing 2 million frames would be impossible. So what we did is we patched Aircrack so that the PTW attack, which is this attack that came out in 2007, which does a different type of cryptanalysis on web and is able to